In the beginning of this lesson, it shares with you at the top of page 331 how exponents are used, and it reminds us that whatever the base is, and whatever the power is, causes the result to be a product, so to speak, of the base multiplied by itself as many times as the power indicates. Okay? So 2 to the third power is the example they use, 8. You guys know that. A couple of outliers, 2 to the 0 power. What does that mean? You're going to learn about that today. 2 to the negative 1 power. And what does that mean? Situations like that are a few of the examples of what I'm going to teach you today. Now, just to give you the easy one right off the bat, anything to the 0 power is 1. 900,673,012 to the 0 power is 1. Okay? This one is easy. Anything to the 0 power is 1. We're actually going to learn about that on the next page. But this, my friends, is where the definition of a to the negative nth is going to help us. It's in the gray box, a third of the way down on the page. And any number to any negative power is equivalent to 1 over that number to the numeric value power. Okay? This is the definition they provide for you in the middle of or the third down of the page. So using the one they just gave, or what I just gave you, 2 to the negative first is equivalent to 1 over 2 to the first. Okay? So the a is the 2, the negative 1 is the n, and anything to the first power is that number. Okay? So this definition here is a lot of what we're going to be practicing today. Here's another sample that's just like it. 3 to the negative third power. Okay? 1 on top, 3 to the third on the bottom. Anybody know what 3 to the third is? Yep. And there's your answer. Okay? They give us several examples. We'll work those as well. Here's A. 10 to the negative third. First step. What do you do first? 1 over 10 to the third. Final step. Simplify 10 to the third. 1/1000. Awesome. B. 5 to the negative fourth. First step, 1 over 5 to the fourth. Plug into your calculator to find out what 5 to the fourth is.
It's 625.
Yep, 625. Good. Example C, last one. 16 to the negative first. 1 over 16 to the first. And any number to the first power is that number, 1/16. Okay, so it's a pattern. Start with what they give you, move it down with a positive exponent, simplify the exponent, and there's your answer. Okay? We did the a to the 0 is 1. Now, where it can get a little bit tricky is when we get to example 2. This section here is a reminder of the rules for exponents. So I'm on page 332. Move to page 332 with me. Whenever you are multiplying powers with the same base, add the powers together. Okay? Add the powers together. Notice there they've got, what if you're multiplying the same base, a positive power and a negative power? 2 to the third multiplied by 2 to the negative fifth. Multiplying exponents, you add the bases. I hope you're all looking at this. Everybody looking at summary rule number 1. Gives you 2 to the negative 2, which is 1 over 2 squared, which is 1/4. Dividing, you still use the same rules that you've used all along. Dividing with the same base, you subtract exponents. The result of 6 cubed divided by 6 to the 7th is whatever the result of the exponents being subtracted. 6 to the negative 4th, you have your answer. Whenever you have a power being raised to a power, you multiply. 2 to the third to the negative second power becomes 2 to the negative 6th. Whenever you have something within parentheses that is another product being raised, both of those items receive that exponent. In example 5, whenever you have a division problem being raised, both of those items receive that exponent. Example 2 helps us to actually use those rules. So we're going to do some of these. Here's A. A says, what is the result of 5 divided by 5 to the negative third? What is the result of 5 divided by 5 to the negative third? So that would be summary rule number 2. Subtract the exponents. But there's no exponent here, so what do? What is the exponent if a whole number doesn't have one? 1. Bravo. So, to solve, you subtract the exponents. Everybody seeing that so far? This one's easy. You don't have to do anything weird. You're going to end up with a normal answer. No negative exponent here. 5 to the first divided by 5 to the negative third is the same as subtracting exponents. And there you have it. That's rule 2. Rule 3, or letter B, is b to the negative 1 raised to the negative third power. Rule 3 states, whenever you have something that is already a power being raised to a power, you multiply the two exponents. So it's going to be negative 1 multiplied by negative 3. B to the third, easy peasy. Whenever you have a power, a product that has an exponent being raised to a power, you might have to combine some rules. Notice example C, they say rules 4 and rules 3 are kind of being combined here, and that's exactly right. Here's example C. 3x to the negative 1, oops, that 1 got too big, sorry, to the negative 1 raised to the second power. Okay, each piece, that shouldn't be a 7, rawr. Each piece within here is getting squared. 3 squared is 9. I'm not sure if this pen has much life in it. And x to the negative 1 squared is multiply your exponents. Nine x squared to the negative 2. I'm sorry. I'm not done yet. I'm going to go get a writing utensil that actually operates. Okay. X to the negative 2. The 9 is being multiplied by x to the negative 2. So you have to view these as 9 times x to the negative second. Okay, I wrote that separate for a reason. This 9 is not to the negative second, okay? The x is. If you notice back on page 331, when we first started this adventure, if I just said to you, simplify x to the negative second, you would say, well, it's 1 over x squared, right? But now I'm saying 9 times x to the negative second. That means the simplification of this gets multiplied by 9. And that's how they came up with 9 over x squared. Okay? The 9 is not receiving the x to the negative 2. Only the x is. The exponent affects the previous thing, not the entire, not the 9 as well. Okay? So simplifying x to the negative second on its own looks like this. Including the 9, because that is being multiplied by x to the negative second, forces us to have to multiply the 9, giving us example, or the answer to example C. I'd like to do a couple more with you. Look at this one. And this one. Okay. This isn't in the example page. I just want to do these with you. What do you think you do in this first one? What do you think you do first? Did you say? Good girl. 6 to the negative third it is. Which becomes 1 over 6 to the third. In your calculators, what do you get? 216 is right. Thank you. Okay. Kenzie mentioned the parentheses. The next little puzzle does not have the parentheses, so you have to treat these separately. And if you think about order of operations, powers, exponents, roots, parentheses, those are done, or parentheses is done first, exponents is second. So we have to deal with the 3 to the negative third, don't we? That makes this become 2 times 1 over 3 to the third. Just like that one up here. 2 times 1 over 3 to the third. What's the end result of that? 2 over what? Good. Bravo. All right. Then what about this? Two very similar looking situations, but different results. Okay, Kenzie already told us we got to do parentheses first. So 2 to the negative first becomes 1 over 2 to the first, which is what? Say again? 1 over 2. 2 to the negative second becomes 1 over 2 to the second, which is what? 1/4. The sum of that is being raised to the negative first power. So 2/4 plus 1/4, or 2/4 minus 1/4 is what?
1/4.
You guys see how I just changed it and did it?
Yeah.
Okay. 1/4. All of that is getting raised to the negative 1 power.
So, because it's a fraction, we flip it?
That should be combined, Mrs. Myers. Gee, we need crickets. 2/4 plus 1/4 is 3/4. Thank you. There. Yes, Noah, you are exactly right. What this now means is 3 to the negative 1 over 4 to the negative 1. Now, this you have not seen yet. If I said to you 3 to the negative 1, you would say 1 over 3. Okay? If I said to you 1, this is so weird to show, 1 over 4 to the negative 1, if there is a negative value in the denominator, it causes that to go to the top. So this caused that. This is going to cause that. Okay? Whenever there are negative exponents in the bottom, it moves that item to the top. Whenever there is a negative exponent in the top, it moves the item, or in the bottom, it moves the item to the top.
So is your answer 4/3?
4/3 is your answer. This is one of the toughest things to handle. I want to give you another example just like this before we move into this. Okay, this is the same thing, only I did a negative 2. So 2 to the negative 2 is in the numerator, which means it goes to the denominator. 3 to the negative 2 is in the denominator, which means it goes to the numerator. I got 9/4. Okay, this received that, goes up, that receives that. In effect, wherever a negative exponent is, causes it to become its reciprocal. Okay? That's another way of explaining that. Let's do this one next. I'll do it on the next page. 2, negative 1, 2, negative 2, negative 1. Okay, here's that other one I had copied. What's in parentheses gets done first. So this is 1/2 times 1/4, right? One eighth? Okay. 1/8 to the negative 1 power. That becomes 8 to the first. That becomes 1 to the first. Answer should be 8. Now, some of you, if you're anything like me, might wonder why this negative exponent business doesn't cause numerals to become negative in the first place. And exponents themselves, if you think about it, you're multiplying that item by itself. Okay? Well then, shouldn't a negative 1 create a negative number? No. In effect, you're going from, instead of going 2 squared, which is 4, 2 cubed, which is 8, you're going down 1/2, 1/8, 2 times 2 is 4 times 2 is 8, 16th. Okay, so you're almost like squaring but in reverse. Squaring but making larger to the second power in the small direction. Okay? I know that seems crazy, but if I were to go up 2 to the first, 2 squared, 2 cubed. So this is 2, this is 4, so this is 16. And we said 2 to the 0 is 1, right? 2 to the negative 1, 2 to the negative 2, 2 to the negative 3. So this is 1/2, this is 1/4, this is 1/8, okay? So the relationship of the numbers continues to be like it would be with a normal positive exponent, only fractional, getting fractionally smaller. Okay. I'm going to stop right there. I'll do example 3 with you guys tomorrow. Example 3 tomorrow.